Good morning everyone. So I'm going to start this class where we stop in the yesterday. So yesterday we were solve a problem on a wedge product, right? Now observe here. So this note is very important. The wedge product of P form and Q form is a P plus Q form. Thus the product is 0 on E3 whenever P plus Q is greater than 3. ಸೊ ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸಲ್ಲಿ ನೋಟಲ್ಲಿ ಕೂಡ ಹೇಳಿದ್ದೀನಿ ಪಿ ಗ್ರೇಟರ್ ದೆನ್ 3 0 ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ದಟ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿಕಮ್ಸ್ 0 ಅಂತ. ಓಕೆ, ಸೊ ಇದು ಕೂಡ ನೆನಪಲ್ಲಿರಬೇಕು. ಓಕೆ, ಸೊ ಪ್ರೀವಿಯಸ್ ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿರೋದು ಗೊತ್ತಿದೆ ನಿಮಗೆ. ವೆಡ್ಜ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು. ಇಲ್ಲಿ ನಿಮಗೆ ಹೋಮ್ ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ ನೋಡಿ. ಕಂಪ್ಯೂಟ್ ದ ವೆಡ್ಜ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಫಾರ್ಮ್ pi equals x into dx minus y into dy and psi equals z into dx plus x into dz and theta equals z into dy. So in ಕೇಳ್ತಿದ್ದಾರೆ compute the wedge product of the form pi, psi and theta. wedge product of these three ನ ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಗೊತ್ತಾಗಿದೆ ಅಲ್ವಾ, ಯಾವ ರೀತಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು. ಇಲ್ಲೂ ಕೂಡ ಅದೇ ರೀತಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಹೋಗಿ. ನೆಕ್ಸ್ಟ್ third one, compute the wedge product of pi equals x into dx minus y into dy and eta equals y into dx into dz minus x into dy into dz. Here also we compute the wedge product of pi and eta. Okay, so now look here, another note. The wedge product of one form and two forms gives the three forms. ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ, wedge product of one and two forms gives the three forms. This is also very important note. So next we move on to the very important lemma. So that is, observe here. So ಏನಿದೆ, the statement of this lemma is, if pi and psi are one forms, then pi wedge psi equals minus psi wedge pi. Okay, so pi and psi are one forms. Now we have to prove pi wedge psi equals minus psi wedge pi. Okay, now let's start to prove this one. So first we consider, so let us assume pi is equals to summation fi into dx. This is one function, and we assume the another psi equals summation gj into dxj. So these two be the one forms, and now we have to compute the product of these two forms. The product wedge product of these two is given by pi wedge psi equals, so pi means summation fi into dxi, wedge of psi means summation gj into dxj. Now we have to compute the wedge product of these two. So then which is equals to summation I is not equals to j, fi into gj into dxi into dxj. We know that by using the anti-commutative property, so this can be represented as minus 1 into dxj in dot dxi or into dxi. Okay, now minus 1 we have to take minus 1 as outside of the summation. So then the remaining is summation I is not equals to j, fi into gj into dxj into dxi. Okay, again we splitting this as minus 1 into summation gj into dxj, wedge of summation fi into dxi. Again, so this can be represented as psi because we assume psi is equal to this one and pi equals this one. Then we write this as, so this as psi and wedge, this as pi. Therefore we get minus psi wedge pi. So therefore pi wedge psi is equals to minus psi wedge pi. Hence the proof simple ide. ಗೊತ್ತಾಗ್ತಿದೆ ಅಲ್ವಾ? Okay. Next we move on to the another definition. Look here, this is very important definition. Let pi equals summation fi into dxi is a one form on E3, then the exterior derivative of this pi is a two form, and this exterior derivative is given by, look here, the exterior derivative of this function pi is d pi equals summation dfi wedge of dxi. ಸೊ ಇಲ್ಲಿ ಒಂದು ಫಂಕ್ಷನ್ ಪೈ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇದರ ಎಕ್ಸ್ಟೀರಿಯರ್ ಡಿರೈವೇಟಿವ್ ನಮ್ಗೆ ಏನಾಗಿರುತ್ತೆ, ಟೂ ಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ, ಅಂಡ್ ದಟ್ ಕ್ಯಾನ್ ಬಿ represented as d pi is equals to summation dfi wedge of dxi. Look here, in general the exterior derivative transforms p forms into p plus 1 form. Observe here. So in this definition we consider the function pi as a 1 form. After applying the exterior derivative we get the d pi as in 2 forms. Okay, so this means, so we get a, when we after transform the exterior derivative transform, p forms into p plus 1 form. Here we consider p form means 1 form. After the transformation of exterior derivative we get the p plus 1 form means 2 forms. Okay, now look here, the example is, so first we consider the first example. We consider pi is equals to f1 into dx1 plus f2 into dx2 plus f3 into dx3. Okay, so here we apply the exterior derivative. We get d pi equals, so this can be represented df1 wedge of dx1 plus df2 wedge of dx2 plus df3 wedge of dx3. You already well known about that. df1 can be represented as del f1 by del x1 into dx1 plus del f1 by del x2 into dx2 plus del f1 by del x3 into dx3 into wedge of dx1, plus similarly this can also be write like this into wedge of dx2 plus df3 can be represented del f3 by, observe here, del f3 by del x1 into dx1 plus del f3 by del x2 into dx2 plus del f3 by del x3 into dx3 into wedge of dx3. Okay, now we have to find the wedge product of these two. Okay, look here, the wedge product of that can be represented as, look here, del f1 by del x1 into dx1 wedge dx1 plus del f1 by del x2 into dx2 wedge dx1 plus del f by del x3 into dx3 wedge dx1 plus del f by del x1 into dx1 wedge dx2 plus del f2 by del x3 into dx2 wedge dx2 plus del f2 by del x3 into dx3 wedge dx2 plus del f3 by del x1 into dx1 wedge dx3 plus del f3 by del x2 into dx2, this is dx2 wedge dx3 plus del f3 by del x3 into dx3 wedge dx3. We know that the repeated dx's will becomes 0. So we get this one 0, this one 0 and this one 0. Then the remaining, look here, del f1 by del x2 into dx2 wedge dx1 is there. Similarly, observe here, we get del f2 by del x into dx1 wedge dx2. Okay, now by using the anti-commutative property, this can be represented minus dx2 wedge dx1. So this can be represented as del f1 by del f2, del f1 by del x2 minus of this one, or del f2 by del x1 minus of this can be represented as minus dx1 wedge dx2. So here these two are common, we take it this as outside, then the remaining is del f2 by del x1 minus del f1 by del x2 into dx1 into dx2. Similarly, plus, observe here, del f1 by del x3 into dx3 wedge dx1 is there. And look here, del f3 by del x1 into dx1 wedge dx3 is there. So now, so by using the anti-commutative property, this can be represented as minus del f1 by del x3 into dx1 wedge dx3. So these two are, and this one are same, so we take it outside. Then the remaining is del f3 by del x1, this is minus del f1 by del x3. Similarly, so we write the remaining term, that is this one. This one and this one we write as del f3 by del x2 minus del f2 by del x3 into dx2 dot dx3. So this is d pi. So iದೇ ತರ next, so ನೀವು exterior derivative ನ apply ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. Look here, for example 2, let pi is equals to xy into dx plus x square into dz. So here we find the exterior derivative of the function pi, means find d pi. Now d pi is equals to, so d of xy wedge dx plus d of x square wedge dz. Now look here, now differentiate this one, we get x into dy plus y into dx wedge dx plus this is 2x into dx wedge dz. Now observe here, or multiplying this one, or find the product of these two, we get x into dy into dx plus y into dx into dx plus 2x dx into dz. We know that this one will becomes 0. So remaining is d pi is equals to, by using the anti-commutative property, this will becomes minus x into dx into dy plus 2x into dx into dz. ಓಕೆ, ಯಾವುದೇ ಫಂಕ್ಷನ್ಸ್ನ ಕೊಟ್ಟರು ನೀವು ಎಕ್ಸ್ಟೀರಿಯರ್ ಡಿರೈವೇಟಿವ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಗೊತ್ತಿರಬೇಕು. Okay, so in the next class we will discuss about a theorem on this one form. Okay, thank you.